All right, in this 7.3 homework, factoring trinomials of the type ax squared plus bx plus c. So now we have a number here that we have to work with. And recall there are several ways we can factor this. The way we sort of settled on is to do the AC method. And let me just do number one. Recall, we're going to try to break that middle term up. It is. Now, I generally don't care what method you use. The trial and error is actually a little quicker when you know what you're doing. And so AC method is the one where it's easier to teach. So I'm going to say, okay, factors of 6 that sum to 7. Well, that's easy enough. 6 times 1. So 6 times 1 is 7. How am I going to rewrite this? I'm going to say 2x squared plus 6x plus 1x plus 3. And we could have just put x there if we wanted. And now I use my factoring by grouping I've already learned about. I'll group these guys up. I'm not going to have a whole lot of room here. I'll come over this way, so 2. And I can pull out a 2x actually. And what am I left with? X plus 3 plus x plus 3. And now what can I do? Well, I've got my common factor here of x plus 3. And so I can pull that out, x plus 3. And then I'm left with 2x plus 1. All right, let's look at number 4. We have 5x squared minus 13x minus 6. Again, we'll just use the AC method. 5 times negative 6. So we're going to have negative 30. So factors of negative 30, they're going to sum to that middle term of negative 13. Looks like it's going to be 15 and 2. If the 15 is negative, 2 is positive. I'm going to rewrite this as 5x squared minus 15x plus 2x minus 6. And now I'm just going to group up each one of these and pull out my common factor in each group. So the common factor in this first group is going to be 5x. And so what am I left with here? X minus 3 plus, and then what's the common factor in the second group? It's like a 2. And I'm left with x minus 3. And here's my common factor of x minus 3 in both groups here. And so I can pull that out. And what am I left with? X minus 3. And I'm left with a 5x plus 2. As always, I suggest that you FOIL that back out, and you should get this original expression. Now, again, one thing we should always be doing is always look for a GCF. Now, we haven't had it in these other ones, so we haven't had to worry about it. But always look for the GCF. And so let's look at number 11, for instance. So 2x squared plus 6x plus 4. When I pull out a 2 as my GCF, I'm left with x squared plus 3x plus 2. Now I factor this as normal, and you don't need to do the AC method here because we have an A of a 1 here. Now you could have used the AC method here and done 2 times 4, but you would have had an embedded factor of 2 that students sometimes don't see that you got to pull out after you factor it into 2 binomials. So then we can go ahead and just factor this. So factors of 2, the sum to 3 is only one way to do it. So x plus 2, x plus 1, or x plus 1 times x plus 2. So if you use the AC method, you may have gotten something like 2x plus 4 times x plus 1, or you may have gotten 2x plus 2 times x plus 2. And you may not have seen that extra factor of 2. So it's always good to pull that factor of 2 out. Let's do one more. Do one with a negative in it, maybe down here at the very bottom. How about number 20? So what is common in all 3 terms here? A common factor of 5. Pull out 5. And what am I left with? 2m squared minus 4m plus 3. And now we're going to see, can we continue to factor this? So you can use AC method. So 2 times 3, work up here, it's 6. And so factors of 6 that sum to a negative 4. Well, I've got 3 and 2. That's not going to work. 6 and 1, and that's not going to work. So this is as far as we can go on this one. Kind of in the mood to do some factoring. Let's pick another one. Let's do number 17. Okay, so what is a common factor I can pull out of this one? I got a common factor here of 2. When I pull the 2 out, what am I left with? 3x squared plus 6x plus 4. So now I'm looking for the AC method here of 3 times 4 is 12. But can I factor 12 in a way that gives me this middle term of 6? Well, unfortunately, I can't. So I've got 3 times 4, that's 7. Or 2 and 6, that's 8. And then 12 and 1. But none of those are going to work either. Bummer, I was in the mood to factor something. So let me do another one. Let me pull around to 13. So I've got a common factor of 4. What am I left with? A squared plus 5a plus 4. Okay, so we can factor this, right? So I've got a 4. A plus 4. A plus 1. Again, factors of 4. Let's try 21 and 23. We'll see how these turn out. Okay, so here I've got a variable I can pull out, right? I've got x I can pull out, the common factor, and I'm left with x squared plus 7x plus 10. And now I look within here. Can I factor this any further? Factors of 10 that sum to 7. Well, 5 and 2. Again, we have a nice, when a is equal to 1, I love that. Makes these come out a lot easier. But what am I left with? Only one way to factor an x squared, x and x. And so this is plus 5, plus 2. Okay, let's try 23. So 23, I'm actually going to be able to pull out a negative 3x. So I don't like the leading term being negative, so I'm going to pull out a negative. I've got a 3, and then I also can pull out an x. So what am I left with here? X squared plus 2x plus 1. Does this factor any further? It does. So negative 3x, we just bring that down. So x squared is x and x, and then 1, there's only one way to factor x. We can go one more step here, right? We know that when we have 2 copies of the same factor, we can write that a little more compactly as that. Now, I don't know many instructors that would count off if you wrote that and they wanted that, unless that's the exact section you were working on that. But we like to write things nice and compact when possible. Both of these are fine answers. That's slightly better. All right, I hope that helps.